So up till now, and up till 1942, there were still no physical robot present. So in 1945, during the Second World War, there was a need of making devices which can handle material at a distance. For example, during the atom bomb project, when they were trying to make an atom bomb, what they found that because they were handling a radioactive material, they had made a device by which they could manipulate this material from a distance or tele-manipulate it. So this is the device. This is the device which is shown in the picture. This is called a master slave manipulator. And this is made such that there are some joints. They are placed in a hot cell, which is at a distance location from the radioactive material. And this was completely mechanical, and it had some wire ropes and pulleys which was actually controlling the motion of this front manipulator or front end effector. So the human being which was here at this end, and the material was handled by the slave, and all the motion of the joints were controlled by these wire ropes. So this was a completely mechanical setup, and it is a completely mechanical device, and the transmission is done with the help of wire ropes and pulleys. So there was no program, there was no electronics involved, there were no sensors, there were no actuators, nothing. So basically this is known as the father of the robot, which is the master slave robot. So this was the first physical robot that was built in 1945. So the journey started basically of a physical robot in 1945. So what we are trying to see here with dealing all this history and all is that robotic technology have progressed in 3 steps. There are the 3 major steps. So the first one, which changed everything, was the invention of transistor in 1941. So before this, everything was mechanical automation. There was no program, actuator, sensor, and there is no reprogramming. You can't reprogram the mechanical devices like the master slave manipulator. It can't be reprogrammed. But once you had this transistor, from the transistor we ended up making a computer, and then we had microcontroller, then we had this microprocessor. And so basically what we see that the first major change that came up in terms of transistors in 1949, and with that came along the concept of reprogramming. So there was the first robot that was made, which was called as Shaky in 1950 at the Stanford University, and which is a mobile robot. It could do simple move around job, avoiding some of the obstacles. And so because of the invention of transistor, we had microcontroller, and with that we could reprogram the device. And in 1950 the first robot was created, a mobile robot was created, which was called Shaky. Next, in 1952, George Dowell filed a patent for teach and playback devices for NC machines and robots. So NC machines and robots are essentially having the same technology. What I mean is that all comes from microcontroller only. So the control system in the NC machines and the robots are essentially the same. But we'll see in the next slide that basically the CNC machines are not robots basically. But they have the same control system. They are controlled by numbers, and the only difference in the robot, the robotic arm basically moves around, and in NC machine, only the tool moves in the XYZ direction. And moving ahead, this was the clumsy 1950 Shaky robot, which is now, this is the today's scenario, the Simo mobile robot, humanoid robot, which was built by Honda. So this is the NC technology. I think I'll skip this. This is not required. And we have flexible manufacturing system also, which was actually supported by the transistors, and we were able to reprogram and use the flexibility of reprogramming. And this is the computer integrated manufacturing with the help of NC machines. And this is industry 4.0 today, and that's why we are here to study this topic of robotics and automation. In first industry 1.0, we had mechanization, water power, steam power. In the second, we have mass production assembly line where used and electricity was produced. And in third, when this transistor and microcontroller microprocessor came up, we came up with the computer and the automation basically started. And today we are connecting this automation with humans and with artificial intelligence and with data science, and all these new buzzwords are used in today's technology. So it is now more cloud-based technology which we are trying to use. So physically, actually defining robot, actually there is no specific definition, but simply speaking, robot should be able to do the following. It should be able to move around, and it should be able to sense and manipulate the environment, and it should display some intelligent behavior. Intelligent behavior using, obviously using the AI, so that it can take some decisions, like we saw in Amazon robots. There are a lot of 3,000 robots that are moving simultaneously. So the robot itself should have some inbuilt intelligence, so that it can make the decision when to stop, when to move, in which direction to move, and so on. So that's why the CNC machine is not actually a robot. It is called as a machine tool. So why we call it as? Because it does not move. Now you will say that the industrial robot also does not move, but actually the industrial robot, the base is fixed, but the arm is moving all around. You can move the all around in the whole of the spherical space. But in CNC machine, only the tool is moving in X, Y, and Z direction. So this is actually, in that sense, CNC is not a robot. It is called machine tool, and robot basically should be moving around. So another classification of robots is the first generation robots. They were the simple pick and place device with no external sensors. So no sensors, then there was no interaction with the environment. And second generation robot, we had sensors, we had vision, tactile. Tactile is the touch sense, right? So we were able to interact with the environment. We were able to get the feedback from the sensors, and further with the development of smart material and computing power, we were able to provide intelligence to the third generation robots, and bio robots were also coming up, and we are still working on those bio robots, nano robots, smart material, and all. I'll just show what smart material can do. Then we have future robots, micro nano robots, androids, cyborgs, and so on. This is the first generation robot. This is the workspace. You can see this is the workspace. This workspace means this robot will cover a cuboid. This robot will cover a cylindrical area. This type of spherical robot will cover a spherical space, and so on. So we'll be dealing with this. This SCARA robot is basically the first pick and place robot. So we'll see what is the importance of workspace or work volume later on as we proceed in this course. So another very important invention that was done, that was the second generation robots. At the time of second generation robot was VLSI, very large system integration, in which on a single board you were able to fix lot of components and all the circuits on a single board. So you were able to make the electronics smaller, faster, and cheaper. And then we were able to have sensors, which very small sensors, because of the help of VLSI. We were able to use the vision. Looked like cameras were always there, right? But we were not able to integrate those cameras into the robots. Why? Because of the size and because of the large size of the computers. But after the VLSI, everything got smaller and everything was placed on a single board, and all the circuits we were able to place all the circuits on the single board. So now we can use the cameras and we can use the facility or the technology of vision, computer vision and all. We have smart sensors, gyros, inclination force sensor, slip sensor, and all those things. We have speech recognition also, we have AI also. This was all possible by the use of VLSI. Next, the third generation robot, we have new materials. We have built up some smart materials and smart actuators. Why we are going towards small things? Because are interested in emulating biological design paradigm. And New areas are like micro nano robots, vision biorobots and all. Why basically we want to miniaturize everything, and how it is possible. Like suppose you want to scale down something, so you suppose you have a bigger lathe and you shrink that, right? If you are shrinking that, then what will happen? Look, like in materials, what will happen? The material properties are not changing, right? So the amount of force that is, or amount of torque that is required to cut a bigger job piece will be same if we shrink down the machine also. So the actuator will actually not be feasible in the miniature size, because material is same and the amount of torque that is required to cut the material, whether it is of large size or it is of small size, will be same. So the actuator basically will not be fitting, and we are not able to build these DC motors of smaller size, because if we reduce the size of the DC motor, the torque provided is also reduced, and we can't go to a very low level, a very small level of at the nano level or micro level actuators. So we needed this smart material. So we have already moved in this medical field when we are able to send a robot in the arteries and veins of the humans or nerves of the humans for performing the bypass surgery. This is again happening. There are some funny things that are happening, like micro robot dentist which are cleaning your teeth, and then we have this as a robotic hair, micro robotic hair cutter. So you don't anymore need the barber, or don't need to go to the saloon. And this is actually the very good example of smart material. Just look at the video. So you, this robotic arm is not having any actuator. It is not having any DC motor, any motor. This is smart material basically just moving with the supply of electric DC supply. And when we change the phase of the supply, the movement of the material changes. So there are no actuators. This is the movement of the hand or the fingers is just taking place with the supply, electrical supply. So these are called, this is made up of EAP, that is electroactive polymer, right? So this is the future, and you don't anymore need the actuators. And next, these are emulating biology. This is a bird flapping done by this material. This is again just by the supply of electric current. So you supply a fluctuating current and the material is fluctuating. This is a snake of a robot, which is, or a link, which is basically changing its shape just by the supply of electric current. So this is how, when you change the direction of the current, so it also changes its shape. And these are the example of robotics rehabilitation, and where the robots are helping people to move around which are disabled, which can be attached to the human body. And these are already present there. And these are the automated vehicles, automatic car, electric vehicle, electric automatic cars are new buzzwords. They are already there in the market. Then this is the sad robot and the happy robot. This is again the with the use of EAP material. This is also one of the field in which the robots are directly controlled by the brain, right? So this is again a very challenging field which is coming up. This is the driver tracking. They track with the use of cameras, sensors, whether the driver is feeling sleepy or not, and they can just they can just blow up an alarm and they can avoid the accident. And so this you might have already seen the Pathfinder and all. This is the autonomous helicopter. These are prosthetics. You might have already seen in the movies and all. This is a cockroach. These are various examples. I just wanted to show where the robotics field is going on. Surgical robotic surgery is very much prevailing nowadays. It is very much used in surgery and all. These are the educational robotic kits that are available in the market for self-learning. These are all microcontrollers and educational toys and all. So this is how we study the behavior. We are having all the sensors all over the body, and we study the behavior by getting the feedback from the sensors. So learning of the human skills, this is all happening with the robots, and we are trying to make the robot more and more helpful to the human beings. Involving as in playing in with the humans expressions. I have a very good video. I'll just show you in the next class of this facial expression, how these eyes are blinking, this lips are moving, and he is responding as you open your eyes. It is also opening its eyes wide. So this is a very good development taking place of facial expression. Social interaction, which was initially banned because robots could be dangerous, so they were not allowed to interact with the human. But now we are, with the help of psychologists and all, we are involving the robots in the human life, and they can be very well a part of the society. These are pets, various pets. You might have seen this. So this was all about the history and how history of the robots from past, present, and future, and how the robotics field is going all along. And I hope you might have got some essence of this, and you might have got information that where the robotics field is heading, and what are the challenges, and what you all can do. Obviously, this course will be very limited. We will be more dealing with the industrial type of robots, because we need to understand the kinematics and dynamics also. And then we will be learning about the control also. Then we will be learning about the sensors, actuators, and all. So this is all about today's lecture.